Welcome, geometry students. Today we're going to identify quadrilaterals using their properties. Essentially, all that means is we are going to be looking at all the different quadrilaterals, parallelograms, rectangles, rhombuses, trapezoids, and so on, all together at the same time. So the big thing we want to keep in mind is some of our quadrilaterals are parallelograms and others are not parallelograms. So you want to just differentiate between those. So here's a graphic organizer. We're going to be doing a lot with graphic organizers at the end of this unit just to make sure that we understand the differences between the different types of quadrilaterals. So looking at this graphic organizer, we start at a very vague description. We have quadrilaterals, so that just means four sides. And as we work our way down this, we're getting more specific. So essentially what we need to think about is this as like a set of levels, the top being the least descriptive level and the bottom being the most descriptive. So as we work our way through the parallelograms, we have rectangles and rhombuses. Keep in mind anything below or lower in this is going to contain the traits of the shape above it. So for example, a parallelogram is also a quadrilateral, but not necessarily a rectangle, rhombus, or square. But a rectangle and a rhombus are both parallelograms and quadrilaterals. And again, squares that super shape that contains all the properties of the rectangle, the rhombus, the parallelogram, and the quadrilateral. Then we go on to the non-parallelograms. That would be the grouping of trapezoids and the grouping of a kite. So let's look at trapezoids. As we get more specific, we become an isosceles trapezoid. So all isosceles trapezoids are trapezoids, but not the other way around. All trapezoids are not isosceles. And then we have our kite as well. So this just helps us to make sense of how these different shapes relate. So we're not memorizing all the different traits separately, but instead looking at them as a group to kind of save what we need to know. All right, example 1 says to look at quadrilateral ABCD, and it describes it as having both pairs of opposite sides congruent. What types of quadrilaterals would meet this condition? So both pairs of opposite sides congruent would be a parallelogram, and therefore any other parallelogram, such as a square, a rectangle, and a rhombus, because all types of parallelograms have two pairs of opposite sides congruent. A kite has two pairs of consecutive sides congruent, but not opposite sides. And a trapezoid does not have opposite sides congruent, so that would not fit. So just these four would be the specific quadrilaterals that have both pairs of opposite sides congruent. Example 2 says to decide what the most specific name for the quadrilateral is. Now, when we look at this, we would say, oh, it's a square because it looks like a square. That's what we're used to doing in our geometry settings, is just making assumptions. But we want to make sure that we don't make assumptions, but we instead go by the evidence in the picture. So the only evidence we have about this shape is it has these four equal sides. And the only kind of shape that we could say this is that it's a rhombus. So even though it looks like it's a square, we don't have any evidence of four equal angles or four right angles for that matter, or even one single right angle would be enough to show it's a square. So since we don't have that evidence, we can't show that. So our reasoning is there are no right angles, but there are four equal sides. So essentially, this is why it's a rhombus, and then what I just crossed out is why it's not a square, so you wouldn't have to include that in your description. You're going to be dealing with a lot of shapes like this. In fact, in your homework, very soon you're going to see a page where everything looks like a square. But what you're going to do is just use the markings to decide what it is. So you really have to know the traits of the different quadrilaterals very well. And keep in mind, diagonals play a very big piece in that. All right, example 3 says, is there enough information given in the diagram to show that this quadrilateral is an isosceles trapezoid? We need to explain. Well, once again, if you look at this, we don't have a lot of evidence here, or I shouldn't say evidence. We have a lot of evidence. We have 3 angles, but what we don't have is we don't have a picture that kind of gives a better description of what it is. We just have to go by what they're telling us. So the first thing I would do is find angle J. Well, we know the sum of the interior angles of all quadrilaterals is 360. So if we take away angle F, angle G, and angle H, we can find angle J to be 78 degrees. Now keep in mind we're trying to show that this is an isosceles trapezoid. Well, we found angle J, and now looking at our angles, we can show that both pairs of base angles are congruent. These two are congruent, and the upper base angles are also congruent. And one of the traits of an isosceles trapezoid states that if it has both pairs of base angles congruent, then it must be isosceles. So our reasoning is yes, because both pairs of base angles are congruent, so it must be an isosceles trapezoid. Keep in mind, we could go on to show parallel relationships. We have our consecutive interangles as supplementary, so that's how we could show that that would be a parallel base as well. So just a reminder on that use. Go ahead and try your You Try Nows, and we will see each other soon. Have a good one.